which is saying table C2.1 shows values of voltage V and current A recorded by Elena observing different current passing through a torch as voltage was being increased. So you need to know that the torch doesn't obey Ohm's law. So the graph of the torch doesn't come straight. Okay, so we have the grid box here, the voltage starting from 2 up to 8. We also have the current starting from 1 up to 4. So the first question is asking us to state Ohm's law. So we can only state Ohm's law when we remember, or you and I remember this formula. So this formula is current being equal to voltage divided by resistance. So meaning to say that if we have current being equal to voltage, meaning to say voltage or current is directly proportional to the voltage. Meaning to say that if the current increases, you are going to find that the voltage is also going to increase. Another thing that you need to understand is that current, since resistance is a denominator, meaning to say current is inversely proportional to the resistance. This means that if the current increases, you're going to find that the resistance is going to do what? It's going to decrease. So that is what Ohm's law states. It states that current is directly proportional to the voltage and inversely proportional to the resistance. So we can write that one. So that is how you're supposed to answer this question. Then as for question B, it is saying plot a graph of voltage against current. So meaning to say, this is going to be the title for our graph of voltage against current. That is voltage in the y-axis and current in the x-axis, using the values given in table C2.1 on the grid provided on page 20. So what we are going to do here, we can come up with the coordinates, and then we use those coordinates, and then we see what we are going to have. Since this one is in the x-axis and this one is in the y-axis, so in terms of the coordinates, we have the first one as 1,2, the second one as 1.5,3, the third one we have 2,4, then the fourth one we have 3,6, then the last one we have 4,8. So let me just get the same coordinates that we have, and then we use them to plot the graph. So let me just put them somewhere here. Okay, so one thing that you need to understand here is that you need to start with the title. So what is our title? Graph of, so we can say graph of voltage, graph of voltage against current. So against current. From there you are done on part of the title. So maybe a title can carry 1 mark for your graph. So this graph is carrying 4 marks. So like I said, in the y-axis we have voltage. So we can write voltage here, and this voltage is measured in volts. Then on the down part we have current. Current is measured in amps. So we can say amps. So that is what we have. So what is next? We need to come up with the scale. So the scale is the one that we are going to use to graph this graph of voltage against current. So according to how these numbers are in terms of the voltage, let me just show you here. In terms of the voltage, we are starting from 2, 3, 4, 6 and 8. So each grid box here on the graph is representing 2 centimeters. That is from this point here up to this point here. That is 2 centimeters. So what I'm going to do here is that 4 centimeters is going to represent 2 volts. Remember, we are ending at 8. So if this is 2 volts, this is going to be what? This is going to be 4 volts. Then from there I need to count 4 centimeters, that is somewhere here. So meaning to say this is going to be our 6 volts. Then lastly, 8 volts is going to be somewhere here. But remember, meaning to say that 2 centimeters is representing 1 volt. So if this is 1, this is going to be 2, this is going to be 3, again so it's going to be 4, and so on. But what about on part of current? On part of current, we are starting from 1, moving on to 1.5, then 2, 3, then 4. So if we say 1 centimeter, or let me just say 2 centimeters, is representing 1. So meaning to say we're going to have 1, 2, 3, 4. So this length looks very short or very small. So what else can we do? Here we can say that 4 centimeters is representing 1.5. So if this is 4 centimeters here, we are going to have 1.5. Then again, after 4 centimeters, we are going to have 1.5. So meaning to say here we are going to have 3.0. Then adding 1.5 on 3, what are we going to have? So somewhere here, that is where we are going to have our 4.5. So this is what we have. So meaning to say that this is going to be our 1, this is going to be our 2, this is going to be our 3.5 or 4.5, somewhere there. So it just depends on how you're counting. Let's write our scale here. For the y-axis, we are saying that 4 centimeters is representing 2 volts. Then in the x-axis, we are saying that 4 centimeters is representing 1.5 amps. So this is what we have. So we can now plot the graph. So the first coordinates that we have, so if this is 1, 2 is somewhere here, so the point is going to be here. The second one is 1.5, 3. So 1.5 is here, 3 is going to be somewhere here, so our dot is going to be here. Third one is 2, 4. So if this is 3, meaning to say this is going to be our 2. So 2, 4 is going to be somewhere here. The fourth one we have 3, 6. This is 3 and this is 6. The last one we have 4, 8. So this is our 4, and where is our 8? Our 8 is this one, so our dot is going to be somewhere here. So drawing a graph, I'm going to start from here. Remember, you're not supposed to start from 0. So from there, and then the graph here is bending, going upward, up to this point here. So that is how the graph is going to come out. Then from there, we are done graphing this one. Let's see the next questions. So for question C, saying using the graph to determine the resistance of the filament of the torch. So to determine the resistance, you need to find the gradient. So gradient is equal to the resistance. You know to say gradient is equal to y2 minus y1 divided by x2 minus x1. So this is equal to the resistance. So if we choose these 2 points, this one up to this point as well as this one here, we're going to have that triangle. So in terms of the coordinates here, what do we have? We have 3, 6. We also have 2, 4. I think this is 2, isn't it? Yeah, 2, 4. So in terms of labeling these coordinates, we can say this is our x1, this is our y1, this is our x2, this is our y2. So this is what we have. So we can just insert them here. So y2 is 4. Then y1 is 6. x2 is 2. x1 is 3. So what do we have? Here we have negative 2 divided by negative 1. As a result, here we are going to get 1. Let me say we are going to get 2. Remember, this is resistance, so it has to be measured in ohms. So meaning to say our resistance is going to be equal to 2 ohms. So if you don't want to use this method, but yeah, this is the one that you're supposed to use because you are using the graph to estimate. Okay? But if you want, you can just go direct by using the formula. So the resistance is equal to voltage divided by the current. So you choose one point. So if I choose this point here, let's say I choose this point here. So my voltage here is 3. Okay. Then my current here is 1.5. Okay. So if I divide 3 divided by 1.5, what am I going to get? I'm getting 2.0 ohms. So have you seen? So whichever way you go, but go with this one because we are using a graph. We're going to get the same answer. Okay. Then the fourth one is saying calculate the energy distributed by the torch if it operates for 45 minutes when the voltage is 5 volts and the current is 0.25 amps. So here you need to know the formula. So energy is equal to power multiplied by time. So here the voltage has to be in kilowatts per hour. Has to be in kilowatts. Then when it comes to the current, when it comes to the time has to be in hours. So meaning to say we need to convert our 45 minutes into hours by multiplying it, or let me say by dividing it by 60. Since we know to say that 1 hour is equivalent to 60 minutes. So we are going to say 45 divided by 60 for us to convert that one in hours. So I'm getting 0.75 hours. So this is our time. But what about power? Power is equal to what? So power is equal to voltage multiplied by current. Okay, so we have been given the voltage, which is 5 volts, multiplied by the current, which is 0.25 amps. So when I multiply 5 multiplied by 0.25, I'm getting 1.25 watts. But I was saying that here power should be measured in kilowatts. So one thing that you need to know here is that 1 kilowatt is equivalent to 1000 watts. So meaning to say that if we want to convert this power from watts into kilowatts, what are we going to do? We need to divide the same answer by 1000. Then we find what we are going to have. So let me do all the calculations here. So we have energy being equal to power multiplied by time, but we know to say that power is equal to voltage multiplied by current, then multiplied by time. So what do we have in terms of power? So the power that you have calculated there is 1.25 watts multiplied by the time that we have there is 0.75 hours. But remember, for the power I said it has to be in kilowatts. So what are we going to do? We need to divide by 1000 here for us to have kilowatt per hour. Energy is measured in kilowatts per hour or in joules. So we have 1.25 divided by 1000, then multiplied by 0.75. So the answer that I'm getting, let me just write it in standard notation so that we see what we are going to have. So I'm having 9.375 multiplied by 10 to the power negative 4 kilowatt per hour. Or you can say 9.4 multiplied by 10 to the power negative 4 joules. So this is going to be our final answer. Then for the last question is saying, what does it mean in terms of electric energy when the bulb is rated 120 watts? So 120 watts, here what we are going to imagine is that the time is just 1 hour. So we know to say that energy is equal to power multiplied by time. So meaning to say that if we were to find the value for energy, we are going to have 120 watts multiplied by 1 hour. Then here we are going to get 120 watts per hour. So meaning to say that that bulb is consuming 120 kilowatts, that is per hour of energy. So it means that the battery, or let me say the bulb, is using 120 watts per hour of energy. Okay, so that is one thing that you need to know. So the bulb is using 120 watts per hour of energy. That is what it means. So we are done for this question. Thanks for watching, and remember to subscribe for more videos like this.